Welcome to What's New in Edge Computing Platforms, ZEDEDA's latest product updates and roadmap. My name is Robert Bush. I'm with ZEDEDA Edge Academy, and I'll be your host today. Let's take a quick look at our agenda before we get started. So we'll start, and this is just one slide on product themes, really what's kind of driving our product innovation. We'll start with product updates with Daniel Dirksen, Principal Product Manager, and we'll meet Daniel and Deb in just a moment. So these are updates that are already in the product that are brand new, that are recent. We'll follow that up with sneak peeks. So that's a look at our near future roadmap, and that'll be with Deb Ghosh, also Principal Product Manager. And if there's time at the end, we'll have a Q&A session. If there's no time at the end, you'll still get your questions answered. So please do, as the presentation goes on, please do put your questions in the chat. If there's time at the end, we'll get those all answered. If there's not time, we'll get the answers emailed out to you. So let's meet our presenters. So Daniel Dirksen, he's Principal Product Manager for ZEDEDA. He's responsible for the ZEDEDA management orchestration solution at Distributed Edge. Daniel has over 20 years of experience in areas like edge computing, SDN, IP in general. Before ZEDEDA, he had engineering and product roles for companies like Nokia, Ericsson, and Juniper Networks. Deb Ghosh is a Principal Product Manager as well at ZEDEDA, and he oversees the Edge Network Service portfolio. He has over 25 years experience across enterprise networking, edge, cloud computing. Deb brings a wealth of industry knowledge and insight. Prior to joining ZEDEDA, he was VP of Product and Technology at CommScope Ruckus Networks. He's had senior product roles at HCL, Riverbed, Alcatel, Ciena, 3Com, Motorola, and many others. So really some qualified folks and some people who they just drive ZEDEDA's product. With that, I'll turn it over to Daniel to get started.
Yes, perfect. Thank you, Rob. Good morning, good afternoon, good evening, depending on where in the world you are currently. Thank you for joining this session. Also from my side. As Rob indicated, I'll be covering product updates, and the main focus is what has been done in Q3, Q4, the last updates. Before I do so, let me briefly walk you through our overall product direction. When you look at product development directions, we have 4 major product themes, and I'll give you a few examples per theme, but just to be clear, they're not exhaustive by any means. There's many more topics in flight than the ones listed here. So the first theme, innovations, new products and services, is obviously covering like the capabilities, like the end user capabilities that you take from our platform. Today we'll talk about Edge AI and UCPE. One more thing I wanted to at least call out is some of the work we're doing around device clustering. And we won't talk in any detail on that today, but that will be something for a upcoming webinar. The second theme is scaling and efficiency. These are generally platform level capabilities. We'll talk about some network enhancements today. But other things that we've been in recent time working on is some of the Z Cloud infrastructure. So the cloud infrastructure that is ultimately providing the edge management. A lot of that is around scalability, ensuring observability. But we've also done work around different connectivity models, such as public cloud private link interconnects. So if that is a topic of interest to you, feel free to reach out to us offline. The next theme is user experience or UX. There's quite a bit of focus on that in general, and we'll talk about a few of these enhancements in this area as well today. And finally, partnerships and ecosystems. So obviously the objective here is to bring additional value to you, our customers, by teaming up with industry partners. We have recently announced a hardware partnership with OnLogic with the objective to make Eve as easily consumable as possible. And obviously with a hardware partner, that implies pre-validating hardware, pre-installing Eve from factory. So you can order your devices from OnLogic directly with Eve pre-installed. We also announced a partnership with Edge Impulse, which is a company focused on Edge AI. And we'll actually circle back on the topic at the end of this webinar today, so bear with us. All right, so let's dive into the Q4 product evolution topics. And the first topic that I wanted to talk about is some of the work we've done on Edge AI, specifically around enabling NVIDIA Jetson devices. So NVIDIA Jetson is a system on chip that is targeted for edge deployments, and you see in the slide some of the edge use cases to which the NVIDIA platform applies. From our perspective, what we see in our customer base is interest in machine vision use cases, things like PPE, personal protection equipment monitoring, like are people wearing their helmets, for example. Things like license plate recognition, like tracking vehicles over industrial areas, but also quality control, like, do the products that come out of, some manufacturing line, do they adhere to the quality that we expect? Or is the overall infrastructure in the correct shape that we expect it to be in by analyzing any kind of deltas on the production line? So zooming into Jetson devices come in different series and variants, and ultimately they're providing different capabilities and honestly, importantly, performance. So Jetson Xavier was the previous series of Jetson devices, although there's still a lot of hardware vendors shipping devices based on this chipset. And the current series of devices is a series called Orin. So within these series, there's different form factors, as you see outlined. So the SoC, the system on chip from NVIDIA's perspective, is delivered as a module, right? Now, for you and I, that is not something we can consume. So we need either a dev kit, which is something that NVIDIA provides for all of these different modules, or you purchase a device from a hardware manufacturer that builds products based on these modules. And this is typically where it becomes a production-grade device, adding I/O, possibly adding hardening or passive cooling, like in this example with the OnLogic 18 device. So in terms of the ecosystem, obviously NVIDIA being NVIDIA, they have a very broad ecosystem. From our perspective, the focus of the ecosystem is really on this platform layer. This is where traditionally people have been using in the Jetson Linux distribution that the NVIDIA makes available. But obviously our goal here is to provide all of the capabilities that Eve and ZEDEDA device management bring. So device management itself, but also application and fleet management capabilities for this type of device series, enabling ultimately a platform that you can remotely manage, like you do with the rest of the NVIDIA, with the rest of the ZEDEDA install base, and enabling higher layers to consume that platform for your app deployment, app development, etc. So what does it mean to us to support a given NVIDIA device? So this picture is outlining sort of the stack of what the overall construct looks like. So at the bottom of the picture, you see the server or host layer. So from our perspective, our deliverable here is an Eve version that comes with an NVIDIA Linux kernel, as well as libraries, as well as firmware. So all these components are what are typically part of a Jetpack, as it's called in NVIDIA speak, and that are shipped with NVIDIA Linux distribution. So we have taken all the specific pieces, kernel, libraries, and firmware, and integrate those into Eve. Then from an app perspective, we support running containerized apps on top of this platform. And when you want to run containers on this type of hardware, that implies exposing hardware devices, Linux devices, and libraries into the actual containers themselves. So there's something called a CDI, a container device interface, which is a specification for container runtimes to effectively expose devices and libraries to workloads. So that is effectively what we do, right? So we ship Eve with the NVIDIA kernel version, libraries, and firmware, and it embeds CDI files that appropriately describe what you need inside your container to actually consume the hardware. Okay. So a little bit more practical, if you want to get started with Eve on Jetson, how do you go about that? So first of all, you obviously need an Eve version that has NVIDIA support. So today you may be used to pulling an installer from Docker Hub. So today for NVIDIA, we actually require you to compile from source, right? So you see outlined here how you can actually build an installer with the platform NVIDIA, which gives all the capabilities I talked about in the previous slides. So then you can just follow the regular installation procedure and deploy Eve on one or multiple devices. A little bit of background that you see in the middle and the bottom of the slide, but when you dig into what is inside that Eve version, you see the CDI files that I just referred to. So these are embedded as part of an Eve version. And then you see outlined in the hardware model, in the device model, how you can consume this, right? So this is part of the hardware model as you have it in the marketplace. This describes a GPU 0 that is referring to a CDI that ties to a Xavier GPU, right? So this is the way that you're effectively saying this device has a GPU, and now I can consume that GPU from my application layer perspective. And ultimately what it does is it maps to GPU 0 on this underlying Xavier piece of hardware, okay? So there is a small thing that we had to look into in terms of running AI workloads on top of Jetson. For those of you familiar with our platform, when you deploy containers on top of Eve, we typically embed the containers in a so-called shim VM. So the shim VM is a small VM wrapper that adds an additional layer of security and demarcation between the container and the platform. And we do this to ensure that we keep like the edge node as stable and secure as possible, not having the risk of a workload ever interfering with the host level kernel. So it's a security and stability capability. And normally, if you wanted a container to consume a GPU, we would PCI pass through a GPU into the shim, and then basically the container can consume it. The unfortunate part with Jetson is that the GPU inside of the Jetson SoC, it's not connected on a PCI bus. That means you can't PCI pass it through. That leaves another option, which to virtualize the GPU. That implies a certain set of drivers, and unfortunately, NVIDIA does not provide virtualization capabilities for these GPUs. So the short of it is that you cannot pass it through and you cannot virtualize it, which leaves us with the only option left, which is effectively running containers on bare metal. So that's exactly what we do for this use case. So if you want to deploy an application on top of a Jetson device, we have introduced this new container mode that you see highlighted. It's called reduced isolation, which effectively deploys the container as bare metal on the node, so without the shim that I just referred to. I mean, there's a price to pay in terms of demarcation. Unfortunately, there's not much we can do about that. This is the only way to get the container to have access to the hardware, and it's no different from running your container on Jetson Linux as bare metal, right? It's the exact same thing. One thing to note that reduced isolation mode is something we support for ARM64-based devices only, just like the Jetson is, for example. But it also applies to some IMX8-based ARM devices that also have hardware acceleration, so you can use this exact same mechanism for those type of devices. So that basically wraps up what I wanted to say about NVIDIA Jetson support. So in short, there is a Eve version that you can build with NVIDIA kernel, firmware, and drivers included that allows us to consume Xavier or Orin GPUs. And to deploy applications on top of that, we have introduced this reduced isolation mode to effectively allow the container to be deployed in bare metal mode so that it has access to the GPU. All right, I wanted to shift gear and talk about something very different, which is some of the work that has been done around innovations on the networking stack. So for those of you that are familiar with how we connect applications to the outside world, there's a notion of network instances. And one of the things that we have added recently is the ability to have multiple physical external ports connected to a network instance. And what that enables us to do is to allow more flexibility in network designs. I'm going to talk you through these sub-bullets that are listed there. So let me park those for now. The key point here is that this capability is allowing us to bring the complexity that comes with highly resilient environment with multiple connections into Eve and ultimately lead to a simpler application design. And I'll show you two examples to just illustrate that in just a moment. All right, so what is this functionality about and what will you see in the GUI going forward? So you'll see under adapter labels, under adapters, under the node, you'll see a new notion introduced called adapter labels. So what you see highlighted here is I tagged this specific adapter with a label called internet. So you can have the same label on multiple physical interfaces. Then when you set up a network instance, this is a standard configuration for network instances. But what you see highlighted in red is that in addition to the physical ports that have always been there, and the notion of uplink, which has also always been there, we also introduced a few other standard labels, but also my internet label is now visible as one of the user-defined adapter labels. So by selecting port adapter label internet, what it basically means is I'm tying all physical adapters that are associated with the label internet to this specific network instance. So that can be 2, 3, 4, 5, whatever number of physical ports that are tagged internet will now be tied to that network instance. The other thing that we have introduced is today when you define an application, you have to set up a policy control for port mappings, right? Like by default, you can't just access an application. You need to expose port maps so that you can control what kind of access from external is available into a given instance. So what we have done is also added the ability here to select or to provide an adapter label. So this means that I can now, in this example, expose port 8443 on any of the physical ports that have adapter label internet associated. And on any of those physical ports, if I come in on that specific port, you will be port mapped into 443 on that specific application, right? So these are kind of the mechanics. Let me talk you through what it ultimately allows us to do. So I'm not going to go through all of the details here, but let me at least sort of highlight the key points. What you see is an edge node that has 4 physical connections on the right-hand side of the picture. These physical ports have different types of connectivity that they enable. So you see the top 2 ports, they are actually some internet, providing internet connectivity. The second port and the 4th port are actually giving you connectivity to some local HTTP infrastructure. And then there is yet another port that gives access to some local LAN, maybe some factory network or some other thing that is not connected to anything else. So for the app that you see on the left-hand side, to consume all these different types of access and to determine like what the routing should look like to actually send traffic in the right direction to hit internet or maybe this HTTP server, what we do is we set up a number of network instances that are associated with these groups of ports. And then for your app to actually consume or interconnect to those instances, you set up the appropriate number of interfaces to connect your app into the instances. And then you set up your routing table appropriately so that a default route is pointing to this specific physical interface, which will get you into this local network instance, which will get you to those physical ports that have internet access, etc. Right? So you can make it work, but there is definitely a level of complexity involved in terms of how you do this. So with the network instance with multiple ports, we can actually in-source that complexity into Eve, into our solution, and make ultimately the application a lot easier, actually as easy as it can be, as you see in this specific picture, because there's only a single application interface left, and all it does is has a default route to point into the network instance, right? So how does it work? You see these ports with these different types of connectivity. They now have labels associated, and then the network instance, all physical ports go into the same network instance, and the network instance actually has port mapping information, routing information that consumes those labels to appropriately set up the routing inside that network instance to ensure that traffic that needs to go to the internet actually goes out on the two interfaces on the top. So again, the short of it is that you effectively have a very similar scenario as the previous picture, but the complexity is managed by us from a network instance perspective and is no longer a problem or a challenge for the application, right? The complexity is no longer in the application. You can actually offload that to us. And I say almost the same because there's actually some things that we do. For example, we offer probing capabilities as part of the routing table inside the network instance to ensure that ports actually have appropriate connectivity. Yes, in theory, you can also do that in your application, but now we're getting into the next level of complexity, right? So, in short, with this multiple port setup and the adaptive label concept, how it ties to routing and how it ties to port mapping, you can create a much more powerful networking construct as part of the platform rather than having to import that complexity into your application instance. Okay. Then the next topic I wanted to talk about, actually the last topic I wanted to talk about is some work we have done around user interfaces on Eve. So as you're hopefully familiar with, the principle behind Eve is, we want to have a headless way of deploying new sites. And we don't want users to locally interact with nodes. Like the whole idea is to have this as an orchestrated solution, right? To have a central place where you monitor and manage this infrastructure rather than individuals out there in the field, managing all this infrastructure. This is how you make it scalable. The whole notion of single source of truth, the whole notion of fleet management. So that, obviously the focus is on centralized management of this infrastructure. Now, that doesn't mean that, it's not useful to be able to do certain things locally. And there's a fine line between what is a good idea and where does it cause operational pain when you do this at scale. So what we have done with these two enhancements is actually cover some of the UX elements of how to interact with Eve when it's in a distributed fashion. So the first thing that we have introduced is this notion of an Eve interactive installer. So today, if you want to install Eve on a node, you typically run a Docker container that the LFH Eve project provides, and that generates your installer. And what you can do if you want to customize what gets installed on the node, you can volume mount some configuration information into that Docker container, and that ultimately makes it into the installer. And when you then deploy that installer on a node, the node gets appropriately configured. Now, this is fine if, first of all, you're familiar and comfortable with that kind of tooling, but it's a bit more complicated if you're not, right? So one of the things we have done with the Eve Interactive Installer is when the node boots up, you end up in a grub boot menu, and what you can do is in the options menu, select Interactive Installer, and it will actually ask you a bunch of questions of how do you want to install Eve, on which disk, do you want to use EFS, what is the cloud cluster that you are hosted on? those type of questions, right? So instead of having to interact with volume mounting files into a Docker file, you can actually just configure this interactively from the node itself. So that makes it a lot easier for those that have a technical challenge with interacting with the Docker containers. So that's one element of enhancement we have done. The second thing that we have done is introduce this notion of a local user interface on Eve. This is also a text-based interface, as you see outlined in the picture, and that was done on purpose because we wanted the barrier of requirements that you need to fulfill to be as low as possible. So even if you only have a text interface to interact with, this will actually function. And the purpose of the local UI is there's actually a few different use cases. Maybe let me take one step back. When you have a node that is managed by a remote controller and is interacting with the controller, life is good. Life is easy. You have no need to locally do anything because you can do everything remotely. Obviously, the challenge is how do I first get that connectivity there? And secondly, what do I do if the connectivity, for whatever the reason, does not work? Right now, at that point, you actually do want to have some local capabilities to interact with the device. So what the Eve Local UI is allowing you to do is predominantly monitoring. So figure out, are my apps running? Am I connected to the cloud? If there's any kind of attestation failure, why is that the case? Give you insight into what is the status of the nodes. The other thing that it allows you to do is to configure the IP interface to reach the cloud. So let's say I have a node that is being deployed somewhere and I need to do a static IP address. That is a complicated thing generally to do from a centralized infrastructure because it implies that you need to customize the installers for all of these individual devices. We've seen operational scenarios where that information may not be available at that very moment in time. So what the local UI is allowing you to do is actually go to a network interface and configure it appropriately with, for example, a static IP address to make that device connect to that cloud from that specific location. And then from that point onwards, obviously, you remotely manage the device. And the final use case that I wanted to bring up is there's also cases where people are operating in a completely disconnected environment, or at least temporarily disconnected on the road, not having any cellular connectivity, for example, or satellite connectivity for whatever the reason may be. That might be just a property of where that device is located, on a truck or on a vessel, things like that. And also in that case, it is useful to be able to have some local visibility on what is happening on the event. So that's what local UI is automatic. That wraps up the topics we wanted to talk about for the Q4 deliverables. What I'm going to do is hand over to Deb, my colleague, who will give you a little bit of a sneak preview on some of the things that are work in progress and we'll be talking about in more detail in the not so distant future. Deb, over to you.
Thank you, Daniel. Good morning and good evening. Very pleased to be here. We'll be talking, a couple of items, particularly last quarter and a half that we have been working on it. So wanted to share with you. Pretty exciting. So let's, without further delay, let's get started. The first one is what we have done. We have embraced artificial intelligence in our product. AI is pervasive. We all know that. We are seeing it in our kind of daily lives to, some of the product and solutions that are coming out. So without further delay, we kind of thought, how about we deliver the similar capability through our products to make our customers' journey much easier, products a lot more useful to our customers. So we embraced LLM into our UI. So when you come to our UI to say you're doing something on a given UI, page, you're having some questions, you want to know more about it, you could use our AI-enabled chatbot. And that would give you a very, very context-aware response as opposed to giving a more generic response. And more and more will be embracing it on every page as you go from one page to another one, and you could use that just kind of a helping hand if you need some help and knowing certain aspect of those UI or knowing certain items that you're working on. This is a great tool that would be helping you. And we tap into the knowledge base of the product. We tap into where you are relative to the product itself and what you are trying to do. So you'll see we're going to enhance this product more and more in coming quarters, but we're very excited that this product will be introduced very soon with our next product rollout. The next one, wanted to touch base on another large topic. And before I go there, let me recap a little bit. A lot of you already know what is universal CPE, but just to recap, traditionally all the network functions that gets delivered, typically through a purpose-built type hardware. Every function requires you to have a separate boxes and configure them separately, bring them together to get a optimal results. And sometime back, people in the industry started thinking about how do we kind of converge them and virtualize them. And that led to these initiatives around, what can we do, leveraging a generic hardware and then bring in these network functions on top, thereby, having this complexity taken care, obviously the added benefit of reduced CapEx, reduce OpEx, and allow you more flexibility, more adaptability, what you want to do for your use case. So ZEDEDA, we are enabling you for all kind of edge applications as you know us. So we thought, some of our customers would also benefit bringing the network functions onto the same platform. And we have taken the journey to optimize our software to make sure that these works very nicely with hand in hand with all the business applications that you are using us, you are deploying on ZEDEDA platform. So the approach we have taken, slightly different than traditional network vendors. We want to enable you to bring your network functions onto the edge devices that you have, whether you're deploying in a distributed locations, retail locations, branch, or anywhere you're deploying edge applications such as oil field or shipping container. And I'll touch base a little bit on one of those that we're working on. So essentially what we're doing in our first phase, we are enabling you to bring your VNF, CNF onto our platform, and thereby you're getting a single entity where you can manage your business application side by side with CNF, VNF, and they kind of work quite nicely, all right? So there are two approaches. One is you bring your own licenses and just bring it to this platform, and through our platform, you get going with it. The other one, we are also working with hardware vendors. You saw the likes of OnLogic. We'll work with them and perhaps offer you as a package solution if there is such interest. Basically, we're enabling the infrastructure element of UCP solution. At some point in the future, we'll work through partnership to bring some of these best of the breed VNF, CNFs, such as SD-WAN, firewall, onto our marketplace, and would offer you through our marketplace for your consumptions. So that's our future phase on this product line. So let me recap a little bit the architecture. So this is kind of how we do things in ZEDEDA world. Obviously EVE is our foundations that works on any hardware. And you're all familiar, how what we do through enabling you to bring applications, whether you're bringing on a virtualized environment or container, we let you do well. Now we are, same platform, same look and feel, same type of experience that you are familiar with through our Jet Cloud. We're enabling you to bring VNF, CNF, and deploy it on the same platform. So that's the holistic approach that we're taking, so that we're taking out, having to learn even new platform, having to do certain new things. The familiarity of the same platform comes into play here. So that's our approach, and we're just adding the VNF, CNF. Obviously, under the hood, we have taken certain steps to make our networking stacks more resilient, more higher performing. Now, here is an example of deployment. On the right, obviously, you have your own, legacy applications, perhaps running on a VM or running container. You are all familiar with how you do that. Gets orchestrated, managed through our Jet Cloud. We are enabling you to, again, bring it on. In this case, an example of SD-WAN or firewall, service chain them as you feel appropriate, and then let the business application consume those services on the same platform. So you're combining a lot of these activities in a single box, and thereby we're delivering a great value to our customers that they have one place to look into, one place to manage, taking out complexity. Obviously, this also has, as I mentioned, benefit of lower CapEx, lower OpEx, because you're not managing multiple devices, multiple items there. At future, we're going to bring more automations through our marketplace. So you look for that as we evolve our product line. So here's an use case, one of our MSP customer, how they are using our platform to deploy network functions. In this particular case, they are deploying SD-WAN along with a firewall and a point of system sales application on the same platform. So as you can see, through our platform, they deployed side by side, and they are scaling into that platform across once they deployed into one particular locations, now you take that model and deploy it across multiple sites. So it makes it a lot easier, one single focal point where you define, and through that, you manage and orchestrate your entire fleet. Next one is a shipping container vessels. This is slightly different applications. We have the same set of basic platform, which is your generic hardware or generic compute platform. You deploy our Eve, and then you bring in through our platform. In this case, they're enabling SD-WAN, and they're bringing in a packet core alongside with SD-WAN to have that connectivity piece on those shipping vessels. So as you can see, our platform is very wide, capable of running pretty much any CNF, VNF that you want to deploy on your use case. And we're here to give you same setup experience that you are familiar with our Jet Cloud. So that's essentially we're giving you another tool that you want to use in your edge journey. So that leads to the Q&A. I'll hand it over to Rob. Rob, take it over, please.
All right. So at this point, as Deb said, we're in Q&A. There's only been one question in the chat so far. The question being, when looking at using our label-based multipath routing, the question from Ronald was, so this is basically Kubernetes networking, correct? And Ronald, if you can unmute to elaborate.
When this question was asked, it was asked when Daniel, when you are presenting the network incident and port mapping.
Yeah, I'm not entirely sure on the direct relation back. I mean, if you think about how we do networking, in the end, the networking is done by the Linux host, right? So it's based on Linux bridging. It's based on NAT for local network instances. So like in terms of like it's not CNI based or something like that. If that was the question, Ronald. But in terms of like conceptually of how you control like at the infrastructure layer rather than at the app layer, in that sense, yes, right? So if that was your point, like basically having ETH0 out from your app and have the rest of the infrastructure take care of the specific routing, then yes, in that sense, it would be alike how that is done in Kubernetes space. Ah, I see Ronald responding. Okay, so I think that's answered.
Any other questions? Please do just put them right in the chat. So there's a couple questions in here. Tom asks, in one of the slides, I saw mention of Open Foundation. What is that?
So, well, I'm not sure on which slide Tom saw that specific comment, but in terms of open, right? Like there's obviously Eve OS is an open source virtualization solution, right? In terms of like its heritage or history, I mean, it was originally developed by ZEDEDA, but it has been donated to the Linux Foundation. So it is a not only open source, but it's also an open governance project, right? That we as ZEDEDA still, obviously commit and contribute to. But strictly speaking, it is open, right? So if you wanted to add capabilities to Eve, and you add you create a pull request, assuming that it fulfills, like the direction of Eve, and it fulfills the technical requirements, right? Obviously, there's a whole review process, but you can add, right? And we had partners, we've had customers that contributed code to Eve. So in that sense, like the foundation is 100% open on the Eve side of the house. In terms of like the openness of Eve, I think there's one element or another element that I've heard from customers and prospects that they appreciate, which is the ability to vet basically the operating system, right? You have full access to the source code. It means you can run your own security audit. I know that we have customers that run security audits or hire external security firms to actually do penetration testing against Eve. So all of those things become possible because of that open foundation.
Also, the question. Oh, go ahead.
No, I think you wanted to do the same thing as I wanted to do, so I'll leave it to you, Rob.
Question for air-gapped environments, no internet access. If customer would like to update one of those, what's involved in that?
Yeah, so we have, I think, a quite unique and interesting approach to how to deal with air-gapped devices. So maybe let me start by saying that, as I was saying somewhere earlier in my presentation, the idea is that we want to centrally manage a fleet of devices, right? Including like the notion of managing the state of a large group of devices rather than like think of it as cattle, not pets, right? That discussion. So how do you do that in like an air-gapped environment, right? Because you don't have your central orchestrator that can actually get to a device, because there is like no connectivity allowed. What you can do in that case is actually prepare configurations in zCloud, so in the controller. And even though the controller cannot talk to a device, you can download configurations for your device, and through any means available to you, get that information to a device, right? That effectively gives you still fleet management capabilities, because what I can do is I can have a fleet of, say, 300 devices, out of which 50, for whatever reason, are not connected to the network because they're in high security type of environments. I can still like do an update to a project that has these 500 devices. So I'm bumping the application version from A to B. And then for those devices that are air gapped, I can actually download those configs. And we have some tooling called Edge Sync that allows you to effectively ingest those configs and play them against those devices that are in an air-gapped environment, right? So in terms of like where do images come from? Obviously, one way or another, if you're in an air-gapped or disconnected environment, application images need to come from some local source, right? Because there's no way to pull it from anywhere else. I hope that that explains. I see there's some links being added. Yeah, you're welcome, Ronald.
So I have a question. How do these updates, particularly the local UI for Eve, how does this affect the security?
Interesting question. Thank you. So yeah, I mean, there's a couple of things, right? So first of all, security and security by design is something that we take very seriously. We do a lot of things from like a solution perspective to ensure it is secure. Obviously, you know, we're deploying things out there in the field, and in the field, it doesn't come with any like physical security. This can be, you know, an edge device that is under the counter in a store somewhere, and obviously people can physically get access to these things. So we do a lot of things to secure the device. We have an immutable OS. We don't have any user accounts. You can't like log into the device on a shell. We have things like measured boot, where we measure the software that is running on a given device that ensures that you can't change you know, kernel version, firmware version, BIOS version without that being pre-approved, if this is what you want to do, right? Obviously, this is an option. So to zoom in on local UI, so first of all, local UI is a TTY session. It is an interface that requires you to physically be connected to the device. So it's a keyboard and video that you need for a local UI. In terms of the focus, as I was talking about, the main focus is monitoring of the device, right? Monitoring in all kinds of different aspects, applications, the infrastructure itself, connectivity, things like that. As I did indicate, you can use it to configure network connectivity to potentially set it up initially, or to potentially correct something if the environment had changed that broke your remote access into that device. So that is the only config thing you can do. And one can argue that, okay, if I have this access, I can actually you know, make it disconnect from the cloud, and that is technically correct. However, as I said, you need to physically have access to this device. So you need a keyboard or and a screen connected to this physical device to even consume the UI. And if your intent was to make it disconnect from, you know, the network, then it would be far easier just to pull the Ethernet cable or just pull the power plug, right? In fact, those two actions would not leave a logging trace, whereas kicking off the local UI and making a config change there would. So yeah, this is a very long answer maybe to indicate that there's no new additional security angles to a local UI. It doesn't enable anything that you couldn't already do, meaning potentially disconnect from the network. Again, pulling the Ethernet cable would be a much easier, faster way to achieve the same thing. So no additional angles in terms of risks associated with local UI, if that was the question. I hope that answers, Rob.
Well, no response is a good response. So do you see ZEDEDA doing further integrations with NVIDIA or anyone else in the AI space?
So yeah, I mean, definitely there's a lot of things happening in the edge AI space, and I'm not going to steal your thunder there, Rob, in just a moment. In terms of NVIDIA activities, yes, there is work ongoing in terms of additional NVIDIA platform support, Jetpack versions, like platforms that embed Jetson. There's other things as well. So for example, there is customers, prospects that are interested in things like Halo, which is another hardware accelerator. And there's a few other solutions alike that that people have shown interest in. So like from a device support, from a hardware support, there's various things happening in that space. Yeah, a lot of innovation still happening. And I think in general, right, like Edge AI is really, or AI in general is a real good use case for Edge. And all these machine vision type of use cases, they are a perfect fit for the Edge, because you generally don't want to bring those camera feeds into some centralized cloud and process it there. It makes no sense, right? Usually you don't even have like the connectivity or the capacity to do that. So I think Edge AI in terms of like use case will be a very important part of the edge space in general. I mean, customers are already running this today, and there's a lot of additional ideas that people are working on or are considering in terms of like next use cases. And maybe Rob, you want to say something about the upcoming webinar?
Oh, yes, but let's just finish out the questions. Oh, here.
Okay.
Okay. No, let's talk about it. Let's do it now.
All right.
So do you still have your screen share up? Yes. So ZEDEDA will be is putting on a webinar with Edge Impulse coming up on December 11th. So this is focused around actually exactly what Daniel was talking about, doing vision, doing AI for cameras at the edge. So there is a QR code on your screen. Hopefully it's large enough, and you can grab that QR code. Also, you'll see some links popping up into the chat there. But that wasn't all the questions. So at this point, we'll open up questions to questions on the webinar that you just viewed or the webinar that's coming up. We actually have one on the UCPE, so Universal Customer Premises Equipment. UCPE has been around for a while. What is the ZEDEDA bringing to it that's unique? What are ZEDEDA's benefits versus the traditional approach?
Yeah, I think that's an interesting questions, right? Why us? What we bring is the simplicity. You know us. You already know. You're looking at how easy for you to use us for your edge deployment, and we're allowing you to bring the same platform where you could bring your network functions. Whether you can mix and match. You can have network functions, business applications, and we just talked about AI. Depending on the compute platform that you have for your edge locations, you could run all three together and managed and orchestrated through the same platform. That instead of doing it separately with separate set of learning curves, separate set of the mechanics of doing, plus what we're doing because you are doing on the same platform, under the hood, we're also optimizing our platform. So to us, we're offering you an integrated, infrastructure as a service. I think that's what we see ourselves allowing. Obviously, we're not a VNF, CNF players. We would partner with best of the breed out there. The other added advantage for us is you could, obviously you could do this with other people as well, but you could mix and match. You may choose, the best of the breed SD-WAN from one vendor versus firewall from other vendors. You're not necessarily getting influenced by platform of choice or a certain vendor. So those are the top level that we bring in. In the end of the day, it's the adaptability, flexibility, and simplicity that we bring in. It's the same look and feel, familiar environment, and we're optimizing the stack under the hood to work it better, service chain is better.
Right, and looks like there's no more questions, but just something else. I mean, this is kind of a rare chance for customers to actually sit down with our product management team. What's for customers who have input, who have feedback, and aren't necessarily at one of these webinars? What's the best way for them to send that stuff into you guys?
I think the typical path would be through the ESA or our TAM, right? That is working with you on our products. I mean, for I think for most, if not all, people, we have review sessions, we have roadmap updates. So if that is not the case for you, and there's a desire or a need to do so, reach out to your TAM or SA, and be more than happy to have a deep dive on any of these topics.
All right, thank you. It looks like we're good on questions. Really want to thank you guys, Daniel, Deb, for your time today. I know that your days are meetings back to back to back. So really appreciate you taking the time out of your day. Really appreciate everybody attending. We will have the recording to this made available to you, and you'll get emailed a link to it. And with that, let's wrap up there. Thank you for attending the ZEDEDA product update webinar. Hope to see you in another one soon.